Hi all, welcome to the video lecture on computer network. So in this video lecture we are going to start with our module 5. So the main topic which we are going to discuss in our module 5 are Internet Control Protocol, that is ICMP, ARP Address Resolution Protocol, RARP Reverse Address Resolution Protocol, BootP Bootstrap Protocol, then Internet Multicasting, that is IGMP Protocol, External Routing Protocol, that is a BGMP protocol, IPv6 addressing issues, and a version 6 of ICMP. For the way how I am going to handle the video lecture, the first part of the video lecture I am going to focus on address resolution protocol, that is ARP protocol, and the second half of the video lecture I am going to focus on reverse address resolution protocol, and rest of the video lecture I am going to discuss on BootP, that is Bootstrap Protocol, and the last one will be DHCP, Dynamic Host Configuration Protocol. So now we can move to the first topic in the fifth module, that is Address Resolution Protocol, ARP. So before discussing the Address Resolution Protocol, we have to familiar with some terms, what I mean by addressing, which are other type of addressing we are using. So basically the addressing are of two types. Either we are called it as a physical address or logical address. Physical address is nothing but it is a MAC address. MAC address means that medium access control. It's a hardware identification number that is uniquely identified each device on a network. While we connecting a device on a network, in order to identify the hardware device easily, we are using MAC address, medium access control address. So it's a 48-bit long address. It will be a unique address. That means each device have a separate MAC address. So for example, if I am connecting my laptop with the network and someone is trying to connect another laptop, the two devices having two different MAC IDs. And it's a address provided by the center. In the case of computer, it will be the address provided by the NIC. NIC means Network Interface Control. They are providing the MAC address. So there I have denoted one MAC address. It's a 6 group 2 hexadecimal digit separated by a colon or a hyphen. For example, here it will be 9C-32-4B. So it's a combination of 6 group 2 hexadecimal digit. So the second type of address we will already discussed the last video lecture. It will be IP address. IP address is the unique address, not a unique address provided in the network. There are two types of IP address, IPv4 and IPv6. And the IPv4 we have discussed in our last video lecture. It's a 32-bit address, and IPv6 is a 128-bit long address. For while transmitting a packet over a network, there are some essential components. They have listed the essential components for transmitting a packet: the physical address of the source and the logical address of the source. That means the MAC address and IP address of the source. Similarly, the MAC and IP address of the destination. So while I am sending a packet from a source to destination, the source has to aware of the MAC as well as the IP address of the destination. In certain scenario, the sender cannot able to identify the MAC address of the destination. So that will be a one issue. So similarly, in certain cases, the sender cannot able to identify the IP address of the destination. That means the logical address of the destination. That also will lead to another issue. So in that scenario, there need a proper solution in order to resolve the issue which we have discussed. There is a mapping is needed in between the physical and logical address. So there will be various mapping mechanism will be there. So we will discuss that one in detail. So there will be two type of mapping mechanism will be there. One will be the static mapping and another one will be the dynamic mapping. So in the case of static mapping, then we are going to create a table which containing the logical address and the corresponding physical address. So there we are going to maintain a table which contains both the MAC and IP address. So there will be a certain limitation in the case of static mapping. The two limitations which we are going to discuss, which are sometimes the machine can able to change the NIC card. In that scenario, the physical address will be changed. That information need to be updated on the table in a periodic manner. And another issue it will be in the case of some lands like local talk. While the system reboot every time, the physical address may change. So each time we need to update the physical address on the table. That will be a practical issue in the case of static mapping. So then we go for the dynamic mapping. The dynamic mapping is the scenario in which each time the machine knows the logical address of the another machine. That means while a machine connected over a network, the machine can able to identify the IP address of the another machine easily. Then they are using some protocol to find the physical address. That means the MAC address. So why we go for the mapping is that in order to correlate the logical as well as the MAC address, logical as well as the physical address. For that we are going for the mapping mechanism. In that scenario, the two protocols they have used in the case of dynamic mapping. First one will be the ARP, Address Resolution Protocol. In the Address Resolution Protocol, what exactly they will do in the sense, they will map the logical address. They know the logical address, that means the IP address. They will map the logical address into the physical address. So similarly, one more protocol will be there in the case of dynamic mapping. They will go for the ARP Protocol, Reverse Address Resolution Protocol. In that scenario, they will map the physical address into the logical address. So these are the two mapping mechanisms. So now we can discuss in more detail about address resolution protocol. So in the previous slide, I have discussed what all are the essential components in order to send a packet over a network. There will be 4 essential components will be there. The IP address and the MAC address of the source as well as the IP and MAC address of the destination. In that scenario, we have discussed the two issues, either the MAC and IP address of the destination, which will not be familiar for the source address. So here we are discussing a certain scenario. In that scenario, the system knows the IP address and the physical address. That means the sender can able to identify the IP address of the destination. It need to know the physical address. That means the MAC address of the destination need to be identified. In that scenario, some mapping will be performed. For that, we are going to discuss the Address Resolution Protocol, ARP. The Address Resolution Protocol, they will map the logical address into physical address. And now let's have a look on how the ARP is going to communicate. In the case of ARP, the IP datagram, it is encapsulated in a frame and it will pass to the physical address. For the first, they will form an IP datagram which will be encapsulated and in a frame, and it will be passed to the physical address. So the sender need the physical address of the destination. The person which need the MAC address of the destination but only know the IP address. So while we sending the ARP request access, the logical address of the IP protocol, which they will map the physical address into it. That means they know the logical address, the IP address. They will map the logical address into the physical address, and the ARP packet request, it will be encapsulated and it will be sent to the network frame again. So that will be the basic working how they are going to do the communication. So now we can discuss how the ARP operation will be carried out. So in the I have given an example for host computers which are interconnected like H1, H2, H3 and H4. For example, if an H1 wants to send a packet to H2, there will be 4 essential components which are required. We know that what are the components? It will be the physical address and the logical address of the source, as well as the physical and logical. Physical means the MAC address, and logical means the IP address of the destination. So in that scenario, the H1, they know only the IP address of the destination. For example, if H1 wants to send a packet to H2, H1 only know the destination address of the H2, and it cannot able to identify the MAC address of the H2. In that scenario, how it will work? The H1, they will broadcast the request, that means the ARP request, to all the connected nodes. So I need the MAC address of the destination and address, that means the IP address to which host it residing. I need the particular MAC address from their end. So like that, one ARP request will be broadcasted. So the request will be available in the case of H2, H4 and H3. For the host machine, at that scenario, they will cross check whether the destination IP address if belongs to that particular host or not. If the destination address if not belong to that particular host, it will ignore the ARP request. In a certain scenario, if the destination address is matched with any of the hosts, the particular host, they will going to give an ARP response back to the H1 hosts. That means the response, they will give the MAC address of the machine which they are connected. So it's an easy mechanism. Just the sender, they will deliver the destination address to all the hosts which they are connected. The destination address which belongs to a particular host, that particular host is going to give a communication to the H1 host. So easily they can able to identify the destination address. The 2 points which we are need to be remember in the case of ARP operation is that for the host, in order to get the MAC address of the destination, initially they will send a broadcast request. So it will be available for all the nodes which they are connected. While giving the response back to the host 1, that means the H1, it will be a unicast address mechanism. Unicast will be they have used. That means only the particular host is going to communicate back to H1. So that will be the basic operation they have carried out in the case of ARP operation. So 3 important points we have to remember in the case of ARP. ARP means Address Resolution Protocol. In that we are going to use the mapping of logical address to the physical address. That means the destination IP address we are going to map with the physical address of the destination. So there will be 2 components will be there in the case of ARP request and ARP response. The ARP request which contain the physical address of the source as well as the logical address of the source. So both IP and MAC address of the source should be included in the case of ARP request. And one more thing which will be included in the case of ARP request, it will be the logical address of the destination. That means the IP address of the destination which we will deliver as a broadcast. For the ARP request, it will be a broadcast message. So it will be available for all the interconnected nodes. The case of ARP response, it's given by the node that has the logical address. The node which there belongs to the destination IP address, that node only going to give a communication back to the hosts which they deliver the ARP request. So in that response, it will give the physical address, that means the MAC address of the destination as a unicast message to the sender end. So now we have a look on the ARP packet format. It's a 32-bit packet format. The main field which are included in the case of ARP packet format, which are hardware type. Hardware type which specify the type of the network in the case of ARP request response. And the second one will the field, it will be the protocol type. The protocol type which is going to discuss whether we are using IPv4 or IPv6 protocol. And the third field, it will be hardware length. Hardware length which is going to specify the length of the physical address. And the fourth one will be the protocol length. If you are going to use the IPv4 protocol, it will be the protocol length will be 32-bit. If we are going to use the protocol of IPv6, it will be 128-bit protocol length, and the next field it will be operation, whether we are going to do the request operation or we are going to get the reply request or reply operation. That will be specified in the operation request bar reply field. And the four components, which are vendor hardware address and vendor protocol address, that means the vendor source and destination address, and the target hardware address as well as the target protocol address, that means the destination MAC and IP address.